The diagram shows the variation of information with the time for 5 events. Five events of a single mission in chronological order. So information about the entire mission, especially about occurrences of each event, is made available online real time, right? Okay. Consider the following statement. Only the events P, Q, and R comply with the golden rule of information. P, Q, R. So can you remember what is golden rule of information? Golden rule of information is that the information has its highest value at the creation time, and the value will be diminishing with the time. So information has its highest value at the creation time, and the value will be diminishing with the time. So that is the golden rule of information. For an example, think about the parliamentary election. When election won, and that time it has the highest value of information. People will celebrate, even eating kiribat. So then after some time, people will realize the tragedy. So what kind of thing that they have celebrated? Then they were really upset about the celebration and nothing to do because election was already over. That is the situation in Sri Lanka. But anyway, whatever. So normally when a change happens, okay, think about this Aragale situation, right? Think about this Gota go home the thing, and when actually Gota went to Singapore or Mali, that was the day which has the highest value. But after that, you know what has happened? It's normally it's diminishing. That's the nature, right? Anyway, P, Q, and R are also okay. And what about S and T? S and T is also ST. All are following golden rule of information, because you can see it has the highest value and gradually diminish. So that is not just for PQR, even for ST. Only thing is here actually that S and T started later. P is earlier start, then Q started, then R started, and then S started, then T started. That is the starting time has a difference. That is the only thing. Event S has the highest demand and needs to be facilitated with the highest technical resources. So value of event S is high. So you can say it has highest demand, need to be facilitated with the highest technical resources. Can be true, but not 100%. Okay, the value of an event can be determined reasonably, right? Value of an event can be determined reasonably using the demand for the information about the particular event. Yeah, that is true. Okay, then what's your answer about 32? Bit ambiguous question. So what about your answer? 2000, this is 2019. Yes, Pute?
B and C.
B and C. That is answer number 4.
Yes.
Anything else? So what about A? A, you know, A is wrong.
So only the events.
Sorry? Only?
They stated only the events PQR.
Yeah, they are not the only, they are not only events. So they are like S and T are also complying with the golden rule. That's the thing. Right. Okay. Considering that, we can go for B slightly okay. So we can go for B and C. But like if you consider about like, so this kind of question, you have to think, you have to balance. In this kind of question, you have to balance a little. Balancing means why this balancing? Why it is need to balance? Because like when you, so here actually they have given few answers. They have given few answers. Why balancing is needed? Because when you balance, when you balance, sometimes you When you try to balance, you will see few answers. So for me, actually, I can look at answer number 2 as well as answer number 4. But considering about this, now I have to select in between. It's like a coin. But you know, B has partial, B is like partially correct. Right? B is partially correct, but so this, it can even be wrong also. Right? So that is the risk that you have to take. That is the nature. Because any exam, even, okay, let's say the examination is given to me and you both. Still, still my answers can be wrong. I cannot say I'm a perfect man who can answer perfectly, because we don't know the intention of the paper maker, don't know the intention of the paper composer, right? What intention that he had, because that is actually, there's a communication gap. Sometimes the intention of the composer or the paper creator is to get B as the correct answer. But when I read answer B, I feel it's wrong. So sometimes it can be. Therefore, it's not possible to 100% match with the answer and get 100 out of 100. Sometimes luckily I might get, but it is luckily. But the thing is 90% you should get. That is the thing, that you should reach A. 90% you can get. Anyway, let's stick to BC then. Right, BC then. So the answer is number 4. But A is, obviously A is wrong, because these are also complying with the golden rule. Has the highest value, then diminish. Okay. Consider the following statement related to the nature-inspired computing. This is the nature-inspired. These are kind of like the questions where students have less focus. The reason is these are not really covered in the syllabus. Why? These are last few lessons. These are in last few lessons. You are not going to school sometimes because of that is not covered. And your tuition teacher might think that these lessons are not that much important because you are getting only 1 or 2 marks. They will skip. Or you will also purposely skip, thinking that they will only carry 2 or 3 marks. But these are some interesting topics. Nature-inspired computing. This always, we are in that topic, nature-inspired computing. What is that? In this nature-inspired computing, we look at how these animals, basically, people have done that. People observe how birds were flying. That is the fundamental thing. That is the fundamental inspiration for the first plane, right? Because they observe that there are birds who can fly. The people were thinking, human, they want to do everything that other animals do. So they will wonder, right? We also want to fly. That inspired them. So now also for computing, we are looking at the nature. One thing is ant colonies. I will show you some, I will give you some examples, then it's easy to you to remember. Have you seen these ant colonies? Ant colonies, basically, ant colony is, okay, these ants, insects, basically they are colonized. They are moving as groups. They're not moving alone. See these insects, see these ants, especially black ants or red ants, they are moving as colonies. They are living as colonies, they are moving as groups. Actually, if you try to vanish a colony, maybe if you disturb this colony, or if you keep few ants, collect few ants, don't disturb them much. Maybe you can collect closer to 50, 50 to 100 ants. Don't count, and spread them, or just put them into a bottle and then just release them. So see what they do. Basically, these ants are moving here and there. They don't have any goal. They don't have any intention. These ants are going here and there, different places. But after some time, maybe after 5 minutes, when you're looking at them, you can see they're following a path. Why? Why they're following a path? What's the reason? Right? So that is what the ant colony algorithm is about. Ant colony algorithm is used in artificial intelligence. That means, okay, when these ants are traveling, they release something called pheromone. It's a chemical. They release a chemical and these ants are moving. Okay, let's say another ant move in this direction, and that ant detects here the concentration of that pheromone is high because he's tracing. It's tracing this and detect this concentration is little high. Now, so he also look at, is there any other path? He will find, okay, he will find this concentration, and he will also contribute. Sorry, it will also contribute to this concentration, and it will also follow this path. It will also follow this path. Maybe one or two ants can go wrong, go here and there, but normally as a group, finally they follow a single path. This is applied to drones, and this is applied to robots, because this obstacle avoiding robots, normally when they avoid the obstacles, so they used to follow a path. Actually, this path can be communicated to other robots. Then other robots, without much effort, can follow the lead robot. Actually, this is happening in drones also. There's a lead drone and the slave drones. Lead drone is creating the path where slave drone follows the path. That is also similar to the bird colonies and these bird songs. And fish songs, have you seen this fish song? Song means it's also kind of a group. Song. So these songs are also called song intelligent. Song intelligence. That is also a part of artificial intelligence. Swarm intelligence is basically network of brains. Right? Network of brains here. So that is used in drones, because birds are basically, these bird songs are, have you seen the bird song? Group of birds, they're like this here. They have specific moving pattern. There's a reason for that. These are songs. There's a reason for that. They're moving as groups, and there's a reason. Actually, this can be applied to drones too. This is really useful when attacking enemies. And I think you have seen the fish songs, bee songs, right here. Actually, by acting as a song, they can even attack much bigger fish. Being a smaller fish, they can attack bigger fishes even, because they're as a group. They're moving as a group here, you can see. That is for their protection. They're small, but as a team, they're strong. That's the idea of these songs. They communicate and move according to a pattern and protecting their kids and all from much larger fishes. So that is the swarm intelligence, and that is what the swarm is. Okay, these are parts of artificial intelligence. Okay, in nature-inspired computing, natural phenomena scenario are observed and used to develop computing methods. Correct, right? That is what I said. Now the lesson is done for you. I have covered the theory. That is why I said, so when you come to this class, right? When you come to this class, you will cover theory and practical both. Okay, then what? Artificial intelligence can use nature-inspired computing for improving its ability to understand and solve the computationally challenging problem. Very true. AI can use that. AI, artificial intelligence, can use that. Computing models and algorithms developed on nature-inspired computing can only be used in natural environments. No such thing. It can be used anywhere. So A and B are true. They're asking about the incorrect statement. So it's C only. So number 3 is the answer. It is C only. Asking about the incorrect one. A, B, correct. So I also that's why I said, even if I answer the question, fortunately there is no answer called A and B. So then I will worry what has happened. But here they mention in the bold, they mention it is incorrect answer, right? Incorrect answer is only C. Okay, so let's go to question number 34, 35, and 36. Please quickly go through this 34, 35, 36. What is the correct statement related to system development? Right, here we have learned that in the system development life cycle. 34. Direct deployment, sorry, not development. Sorry, my mistake. It's deployment. Deployment means the last phase of, not last phase, the one before the last phase. After deployment, you have one more task, that is review and maintenance. Can you remember the order of execution of the SDLC steps? The first one is this may differ from your book, from your syllabus, but still, so the order is same, right? The first thing is problem definition, identifying the problem. Sometimes this is dropped. In some of the books, this part is not there. Without problem definition, they start with the requirement analysis. That is okay, no matter. Requirement analysis. And actually under the requirement analysis, there's something called feasibility study. That is what checking the feasibility, practicality of this. Whether it is technically practical, technical feasibility. Whether it is environmentally practical, environmental feasibility. Whether it is economically practical, economic feasibility. Whether it is legally practical, legal feasibility. Whether it is socially practical, social feasibility. Likewise, we have to check different feasibilities. From different alternatives, here we are going to select the most practical thing. There are different alternatives. From that, we are going to select the most practical thing. That is what the requirement analysis and feasibility study. Then we come to the system design. Okay, we have the problem. We found the requirements. These requirements can be functional, non-functional. Functional means main, non-functional means whatever the restrictions that you have in order to implement the main requirement. What are the restrictions? So that is non-functional. Then the feasibility study, system design, and this is where the flow chart, pseudocode, data flow diagrams, use case diagrams, all the diagramming, designing part come here. Then comes the system development. This is where the coding started. Coding starting this phase. And after development, actually after, not even after, with the development, testing started. So you need to test as individual units, system unit testing, test as combined unit, integrated testing, test as the entire system, that is system testing, three tests, unit, integrated, system. Actually, system can be tested on site. That is called on-site testing or alpha testing. Or system can be tested outside, and so with the outsiders, that is called beta testing. So normally a software, when a software release, there's a software called alpha release. In alpha release is tested by the developers, development environment. Beta release is given to the users. Users are also able to, this is given to the users. So it is kind of a user acceptance test. So users can use the beta release and give the feedback. Then comes the full release. Finally, the full release comes. So after testing, after the acceptance testing can be done alpha release, beta release, and after that the full release, that is called deployment. That is handing over the system. Handing over the system can be done by immediately stopping the old system. We call direct implementation. Immediately stop the current system, bring the new system, direct deployment. Then parallel deployment, where both new and old systems are running parallelly for some time. That is for mediating the risk. That is to managing the risk. Because old system is also running, the new system is also running. But you can stop immediately if it is not risky. You can stop immediately, start the new system. That is direct. Pilot means, pilot, something like pilot. Pilot means it's done for some portion. Only a specific portion. Pilot test. A sample is taken, then deploy. Then the next sample is taken, then deploy. That is pilot. Testing for a sample. And then you can deploy pace by pace deployment. The first pace, one section is deployed, the next section is deployed. Pace by pace, that is not a sample, that is directly a particular portion, part, a department. That is pace deployment. And these are the possibilities of deploying. And finally, you have to review and maintain any system. These are the things that we have to take into account. This is called this cyclic process of these steps are called SDLC, System Development Life Cycle, or sometimes Software Development Life Cycle, that is SDLC. These are the general steps of that. Right? Okay, now let's come to the deployment. Direct deployment is the most complex, most slowest. No. It is the fastest. It is the fastest. Because you are going to stop and start the new. Therefore, direct deployment is not the slow. In pilot deployment, all the users have ability to use the system at the beginning? No, for the sample only. In parallel deployment, all the new systems are used in the same time. Very good. That is the answer. 34. It is 3. Situm's answer is correct. Varun's answer is correct. Yes. Is that all? 34. Senali's answer is correct. Madhusha's answer is correct. Okay, I guess that all of you have answered correctly. Okay, good. Then okay. Netuli and Situm, I think so Gavesha is here. Actually, she wants your contact details. I think you can just drop a message to the group indicating your presence, because actually our administration department, they don't have your contact details. Netuli and Situm, this is for you. Please please just drop a message to the group. Then I'll share that indicating that you are participating to this class. Then I'll share your contacts with them. Okay, can be done. Okay, then phase deployment do not allow users to develop skills required for a new system gradually. Phase deployment do not allow users, no such thing. So because one phase is implemented, that phase that users need to know. Phase development means the entire system is used on location. No, it's only portion by portion. Okay, the answer number 3. Consider the following, question number 34. For 34, answer is 3. And question number 35. Okay, Netuli has shared the contact. I think Gavesha, you can use that. And I think Situm can do the same. Okay, consider the following statements. A hub connects only network computers, but switch connect multiple devices. Hub, actually other devices can also be connected, no issue. A switch manage the ports and the VLAN security session. Yes, for manageable switch, it can manage, not all the switches, but a manageable switch can manage. Not all the switches, manageable switch can manage. Can be treated as a correct answer. In data transmission, hub uses bits and switch uses frames and packets. That is correct. Hub uses bits because it is broadcasting. Switch uses frames and packets. Correct. C is correct, obviously. The data transmission speed is hub is higher than the switch. No, it's other way. The data transmission speed in a switch is higher than the hub. So D is incorrect. So other than D, B, C are correct answers. B, C are correct answers. No such answer is there. A. A, B, C ගත්තොත් 1 යන්න පුළුවන්. Hub connect only network computers, but switch connect multiple devices. Switch connect multiple devices, that is true, but hub can also connect multiple devices. It's a bit problematic, but no answer is there. we are compelled to select answer number 1 for 35. Yeah, 35 answer number 1, because this is partially correct, A, but the thing is we have no answer mentioning only B and C as correct answers. Therefore, we have to go for A, B, C, all are correct. But I know that A is not really correct. That's the problem. Right here, let me show a hub. Actually, if you want to connect, so this can be done. But I think because of the broadcasting, this this has come, because that broadcasting can be understood by this. But you can see here the LAN, these images, the LAN connector is basically connecting hub, right? Not just the computers, even this can be connected. That's the thing. Here you can see again another diagram. You can see a hub, computer. There's a printer. There's another printer. That statement is a bit problematic. And even a hub can connect it to router. Without any issue, hub can be connected to a router. Those things are there. Therefore, not a very good answer, but actually switch has more capabilities. We have to believe that. Believe in that. Let's give chance to the switch. The switch is anyway powerful. So what's the difference between like switch and hub? Hub is basically whatever the signal comes to it, it will broadcast. Hub is like a repeater, right? When you say it's like a parrot. When I ask pettabat kævada, the parrot is also asking pettabat kævada. Right? If like parrot is telling yes but kæva, it is something else. But normally the parrot behavior is there in these hubs. Whatever the signal we send, it will repeat. It will repeat and rebroadcast. But switches, selectively it can send to the relevant ports. Relevant. That is the difference. Anyway, let's stick to number 1. It's okay. Okay to go for number 1. But not perfect answer. It's okay to go for number 1. So what about your answers? Okay, 35-1. A lot of people skipped that 35 scenario. Okay, correct. Some have skipped. Consider the following statement about the proxy server. It helps to hide the true IP address. Yes, proxy can hide the proxy is actually something like this. Proxy is appearing as you. Proxy can share internet to multiple parties. You believe in proxy, and proxy is sending the request on behalf of you. So your IP is hidden, proxy's IP is visible to the others. It's like this. You go and you communicate with the help of your father. Let's say in your family, your father is the only person communicating with the outside world. So your father is representing you, your father is representing your sister, your father is representing your brother, your father is representing your mother, everyone. Everyone connects to your father. The father is like the proxy. Okay, that's it. So it hides the IP. I agree, can be selected. It is used to restrict the access. Yes, your father can decide what to do and what not to do because he's the authority. Restrict the access to website because you are going through him. He can decide. Similar to that, the proxy can decide whether to access, whether to allow, or whether to block. It can be used to set the management guidelines. It uses the cache data for the quick loading. Regularly access website, very true. So regularly access websites cached or stored, locally stored in there. So whatever a regular request, the internet will be faster because, so let's see, so this has happened when there was a proxy server in our university. So when people were downloading music and movies, if somebody has already downloaded that movie, So the second downloader will get very fast download because of the proxy feature. It helps to detect because it's already stored in the proxy. It helps to detect the locations of the visitors and load the pages as their needs. Oh, it helps to detect locations of the visitors. Can be configured. It helps to detect the locations of the visitors and load the page as per needs. This can be configured. Okay, we can go for answer number 5. A, B, C, D, all. And even if you select A, B, C, that is also a valid answer because D sometimes you might not consider. So let's go to the marking scheme and see what they have given. So I would like if you can select number like 5 as the answer, but nothing wrong selecting this one according to your knowledge. These are a bit ambiguous, so better go for number 5. So you can check the answer in answer strip 2. I hope that they will give for number 5. And even number 1 is also okay because like sometimes you have doubt in this area, but let's go for number 5. It's okay, clear. Right, 37 to 38 and 39. Please answer now. 37, 8 and 9. Right, question number 37. Which of the following statement is correct about the above circuit? It's implementation of full adder. Yes, there are 2 half adder circuits and that creates the full adder. Okay. The logic function S can be set as S equal A XO B XO C sum. C out can be C out. This sum is A XO B XO C. Okay. C out can say set as AB. AB. Okay, AB here. A XO B C. AB A XO B C. A XO B and C. Sorry, I got disconnected. I think it's okay now. Right, okay. Implementation of full ladder, that is correct. The logic function is can be represented that A XO B XO A XO B XO C. That is also okay. C out is the problem. C out. AB is okay. AB BC. BC AC. That has a problem. There is AXO B. AXO B need to be considered here. AXO B and C need to be considered. Actually, you can write alternative for that. But here the main concern is basically you can take 1, 2 as the answers. Yeah, you can take 1 and 2 as the answers here. 3 is a problem. Okay. Yes, 3 is a problem. Sorry? Hello?
Can't we get the carry with this equation?
Which
Third one?
Third one.
Yes.
AB, BC in, AC in. AB, BC in, AC in. AB is okay, but BC in, AC in. No. Cannot take, right? Because ABO, it's okay. AB is taken. AB anyway you have, but this part you cannot get with that, right? So how come it? But you have to solve it. Solve and then get something like this. But the actual equation, that's the problem. Anyway, so let me write down the truth table and show you this. Right? You can just draw a truth table for full adder circuit and see this. A, B, C are there. So let me explain the nature of full adder first. A lot of students are having this power issue, right? Oh, it's okay. It's okay. Okay, I'll discuss this question and for the moment, and then I'll stop. But the thing is, I was thinking of finishing the paper. It's okay. But anyway, I'll show you the sum and see. So how this happened. So see, you can write down this one as 0, 0, 0, then 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right. Then sum is basically the total. Sum is the total now. Sum can be taken here 0. 0 plus 0 is 0. This is 1. This is also 1. Here 1 plus 1, 2. 2 අපි ලියන්නේ නැහැ. 2 වලින් බිඳුව ලියන්නේ. 1 plus 1, 2. 1, 0. Here 1. It's okay. Here 1 plus 1, 2. 2 වලින් 0 අපි ලියන්නේ. එකක් ඉතිරි එක ඉස්සරහට ගෙනියන එක 100 එකට ලියන්නේ. Here 1 plus 1, 0. 1 plus 1 plus 1, 3. 3 වලින් එකක් අපිට ලියන්න පුළුවන්. Then here carry forward bit 0, 0, 0, C 1 plus 1, 1, 0, sorry, 0. I also get the power issue. I don't know how long my solar will work because the thing is today was raining. I couldn't store the solar power properly. 1 comes here, 1 comes here, and 0 is here. Sorry, 1 is here. Okay, 1, 0, 1, 0, 1, 0. Okay, this is what the sum and carry. Right, when you are adding the numbers, so this is anyway XOR behavior. A XOR B XOR C. If number of ones is odd, then the output is 1. Number of ones odd, output is 1. Number of ones odd, output is 1. Number of ones odd means 1, 2, 3 are there. So output is 1. So that is XOR behavior. I agree with this strongly. This should be the equation for sum. And then this one. A and B, or B and C, or A and C. A and B. So what is A and B? Let's write A and B here. A, B. If A, B both are 1, then this is 1. A, B both 1 වෙන්නේ මොන වෙලාවටද? Here 0, 0, 0, 0, 0, 0, 1, 1. Okay, that is A and B. Then what is this B and C? BC. BC. BC also, BC both 1. 0, 0, 0. Oh, sorry. Light 0, 0, 0, 1. BC both 1. 0, 0, 0, 1. Then again 0, 0, 0, 1. Okay, that is BC here. Then AC. That's why I said, if you solve this, yes. But the problem is directly by referring to that, no. That's the issue. AC, both 1, then 1, 1, 1, 1. No, no. Here both are 1. Here both are not 1. The last one both are 1. Here both are not 1. So you have to take O of this. When you take O of this time you will get 1. That is okay here. And this time you will get 1. That is okay, it's here. This time you will get 1. That is okay, it's here. And this time also you'll get 1. That is okay, it's here. That's why I said, if you simplify, you will get. If you simplify, you will get C out. But if you are not simplifying, if you directly watch at this and then decide, you won't get. So therefore, A, B are directly correct. You can take 1, 2 only as the answer, or you can even get can be stated as this. It's okay. Nothing wrong with that, because that can also be taken. Okay, let's see what about this. But that is not actually the circuit representation. That is taken by analyzing the final results. For question number 37, answer script says all. I think that is the doubtful thing. So answer script gave all for any answer they have given, but all 3 are correct. Is implement a full ladder, that is true. Is adding 2 bits. Full ladder is basically adding 3 bits, giving the sum and carry. A, B, C, adding 3 bits, giving sum and carry, it's full ladder. That is okay, agree. And logic function is sum is this, XO of that is also okay. And this is, yes, this is the final projected output of this one. That is also okay, but not actually according to the circuit. This is not taken according to the circuit. This is not even simplifying. This is another way of getting that. Okay. Question number 38. The participation has a problem. Only you two are there. The problem is like most of the students have sent me the message saying they're having this power cut issue. What can be done? Okay, only for today, it's okay. We have few to discuss, otherwise like other students will miss that. Anyway, then next you have Python, it will take some more time. Right, we cannot finish everything today. Okay, let's stop little earlier. I'm sorry, because of these technical issues. Let's stop little earlier. I'll be discussing the remaining part next day, right? Okay, good night.
Thank you, sir.
Okay, thank you.